only numbers, only angles negative 90 through 90 non-inclusive. Does that make sense? Okay, so they're the basic graphs and what they do, and therefore we can ask you a whole suite of questions about ranges and so on, and just asking you to work out values, and that's exactly what exercise, I don't know why I called this 6E. Is that what it is in the new book? 6D. Okay, well that's what 6D does. Okay, so 6D is just a whole bunch of simpler versions of questions like that, with a bit of graphing, bit of domain and range. That's all it is. Now there are some hard questions towards the back of exercise 6D, but we'll cross those bridges when we come to them. Okay. Does anyone want to ask anything about that? The only thing I really want to hammer with this is just what arc sine means.
You're right, it is 6E. I think it's just 6E, and then 6D is just more simple for the other identities.
Oh.
Should we do 6D?
Oh, okay. Sorry, have I told you something you didn't want?
Yeah, potentially.
Okay, sure.
Would they ever ask you outside of pi over 2? Like how you've done
I did.
Yeah. So would you...
Yeah, completely.
0 every time?
You just got to think. Monsters, sine, cos and tan, they do their standard thing. They can work on massive angles, right? And they spit out a small selection of answers, except for tan, which can spit out anything. Sine and cos only ever spit out angles between -1 and 1. Okay? But the inverses have been specially designed to work on numbers -1 through 1, but they do not spit out whole Pasquillian answers. They only spit out a very tiny selection of angles, which is -90 through 90 inclusive for arc sine, except it spits it out in radians, which is -90 through 90 non-inclusive for tan, and 0 through 180 inclusive for cos. Does that make sense? What I just went through there was the ranges of the three famous arc functions.
Okay.
We cool with that?
Yeah.
Shall I just quickly explain what the other thing was? The thing that I forgot, 6D? Yeah, it's really simple. It's just basically, in Core 2 we always had that. Now you got a new one. Your new one is this. Yeah? That enables you to make 6 replacements. You can replace that with that. You can replace that with that. You can replace this with this. You can replace this with this. You can replace sec squared theta minus tan squared theta with 1. And you can replace 1 with sec squared theta minus tan squared theta. You cool with those? And I think that's it. Oh, the proofs are really easy. You just divide all 3 terms of this by cos squared x, cos squared theta. If you divide everything here by cos squared theta, this will become a 1, this will become a tan squared, and this will become a sec squared.
Yeah.
If you divide everything by sine squared, this will become a cosec squared, this will become a
Sec squared.
a 1, and this will become a cosec. This will become a cot squared theta. So in fact, that's what I'm now going to tell you. Cot squared theta plus 1 equals cosec squared theta. Yeah, so here are your 2 new fellas, that and that, each enabling you to make 6 replacements. They're just the Core 3 version of that from Core 2. And then other than that, it's the same old. And that's what you see at the head of 6D. We cool? Okay.
Are
you guys doing 60?
Yeah. How do you do 180?
Set squared half
Using the
pizza.
rule, but you just have the same pizza retracted as half pizza. So sex squared, half pizza, yeah. So it doesn't affect the one? No.
No.
Using the whole
I was looking at it, like, what is he talking about?
I assume so, yeah.
Oh, yeah.
Probably, yeah. No, that would make sense because then we don't have to learn anything else. So 60 today. I like it when other people say it as well. So
Yeah.
60 next lesson.
Yeah.
So yeah.
Whenever I'm learning.
Whenever else is learning it, we'll be doing it, which is
Wait,
quite
so
nice.
we're just doing
Yeah.
16 right now?
Yeah.